Energy stored in a capacitor. When we charge a capacitor, how much energy it stores? So that we can obtain by a formula, and that formula we have to derive here. So we consider a capacitor of capacitance C charged by DC source whose potential is V as shown in figure. You can see here capacitor. It is charged by a source whose potential is V. Now I consider here Q is the final charge, V is final potential. When it is fully charged means when it is a maximum value of the charge. The final charge is Q, V is the final potential. Then capacity is given by formula Q by V. Capacity is given by formula Q by V. And you remember one thing here, capacity is constant. So during charging means what? When we have started adding charge on this capacitor plate. So during charging at any instant, I consider here it may be we have to consider small q is the final, small q is the charge, small v is potential. During charging, q is the charge and v is the potential. Let us use small v for this potential. Then capacity is given by formula q dash by v. Let's say q dash is the charge. Q dash is the charge and v is the potential. So we get capacity is q dash by v. And both the capacities are same because capacity is constant. A small amount of work done. Now you have to add, pay attention, we are considering a case during charging. So this is very important. During charging we have to consider. So q dash is the charge and v is the potential. That time this is the capacity. So when we want to add a charge dq on a plate, so pay attention, when we are adding the charge on a plate, so this is a plate, this plate already having a positive charge, one more plate we can consider this plate having negative charge. When we are adding a charge on this plate, then I consider the charge is dq. When we want to add a dq charge on this plate, so this is a positive charge and this is a positive plate. So this positive repulsion is there. Against that repulsive force, we have to do some work to add that charge. And that work done we have to write. So pay attention here. Small amount of work is done if a charge dq is further transferred between the plate. When we add this charge dq on the plates, some work is done. And that work done is given by formula V into dq. So this work done is given by formula V into dq. So we know the formula of potential dw by q. By using that, work done is equal to V into q or V into dq. So we get the work done. So but V, by using this formula, so V is equal to q dash by c. So this formula we substitute here. So we get work done is equal to q dash by c. Q dash by c into dq. So this is the work done to add a small charge dq. We have to find out work done, total work done to add a charge q. So because the final charge is q, so we have to find out work done to add a charge from 0 to capital Q. So total work done in transferring the charge is given by formula integration of dw. But integration of dw within a limit 0 to capital Q. Now let me substitute the formula of dw here. ठीक है. So we get integration 0 to q dash by c into dq. Now we take a constant outside. C is a constant that we take outside. So 1 by c is outside. So integration of q dash into dq within a limit 0 to q. Now integration of x dx is coming x square by 2. So q dq is q square by 2. So it's a q dash. So q dash square by 2. Now we have to substitute the limit. So initially, instead of q dash, we have to substitute upper limit, then minus sign, and then lower limit. So we can write like this: 1 by c q square by 2 minus 0 square by 2, 0. So we get formula 1 by 2 q square by c. So this is the formula of work done. This work done is stored in the form of potential energy. This work done is stored in the form of potential energy. That potential energy we can write by symbol U. Hence we can write potential energy is equal to, or you can write electrostatic potential energy stored in capacitor is equal to 1 by 2 q square by c. So this is expression for energy stored, or electrostatic potential energy stored by capacitor, q square by c, 1 by 2 q square by c. This energy can be expressed in different forms as follow. We know the formula C is equal to Q by V. So by using this formula, C is equal to Q by V, we can write this energy stored is equal to 1 by 2 CV square. Now how we write? U is equal to 1 by 2 as it is. By this formula, Q is equal to CV. So we can write instead of Q, CV. So we get C square V square by C. So this C and this C get cancelled. We get 1 by 2 CV square is the energy stored. So here we substitute Q is equal to. So instead of Q we substitute, so we get this form. Instead of C also we can substitute Q by V. Instead of C we substitute this formula. Then what we get? So we get formula 1 by 2 QV. So you can see here we get 1 by 2 Q square divided by C is Q by V. So we get 1 by 2, this Q and 1 Q get cancelled. 1 by 2 QV is the formula. So this is expression for energy stored. You can remember different forms for the problem. This is the first equation, second equation, third equation. All the three equations are equivalent. Any one you can remember for the problem, and then as per the given you can substitute this in that formula to obtain the different forms.